Hi everyone. This week we're going to look at some formulas that can help you guys out with these trig functions. And the first thing I want to mention, something we did mention earlier this year, whenever you have a trig function, the thing that comes right after it here, that's the angle in the question. And usually the angle is just one single thing, like I said in the note, sine theta, or it could have been tangent x, or cosine of pi over 3, or something like that. For this next week, we're going to look at some cases where the angle is a little bit more complex. Like today, we're going to look at when it's a sum or a difference, addition or subtraction. So we might see something like sine of x plus pi, that's a sum, or tangent of alpha minus beta, that's a difference. And we want to basically break those up. You know, a lot of times in the question, if you have something like that sine of x plus pi, you want to split that up. You want to have the x and the pi separate. So first of all, let me talk about what you can't do. You can't just split them up. That's not how it works. There's no distributive property for trig functions. So I said here, if you have sine of x plus pi, it definitely does not equal sine of x plus sine of pi. You can't just split it up. Instead, we're going to learn some formulas on how to do that, how to split it up. So what I'm going to do, I'm going to go over a total of 6 formulas with you guys, 2 each for sine, cosine, and tangent, both a sum formula and a difference formula. So let's start off with the sine formulas. We have sine of u plus v and sine of u minus v. That's our sum and our difference. U and v can be anything. And what I want you guys to notice here when you look at these is the formulas are exactly the same. You have sine u cosine v here, sine u cosine v here, and then you have cosine u sine v, cosine u sine v. The only difference is the sign, and the sign matches up. When you have a plus here, you get a plus in your formula, and when you have a minus here, minus in the formula. So nice and easy to remember because they're almost the exact same formula. Then we have a very similar situation for cosine. What we do is we group the two functions together. So it's not sine cosine, it's cosine cosine, sine sine for both formulas, cosine cosine, sine sine. And what's important to notice is the sign switch this time. If you have a plus here, you have a minus in your formula. And if you have a minus here, you have a plus in your formula. So there's patterns here. It'll help you remember them. Now the tangent formulas look like this. They're a little bit different. There's some patterns here too. I will say this first of all, the tangent formulas come from taking the sine formula, putting it over the cosine formula and simplifying, because tangent is sine over cosine. But what I want you guys to notice is, again, it's kind of the same formula, the sign switch. So what you have is, when you have a plus in your formula, you have a plus on top and a minus on bottom. And when you have a minus in your formula, minus on top, plus on the bottom. But the rest of the formula is the same. You have tangent of u plus or minus tangent of v on top, and then on bottom you have 1 with either plus or minus, and then tangent u times tangent v. So we want to use those 6 formulas to solve some questions, and before I do an example, I want to talk about the reciprocals. So we have a total of 6 trig functions, but we only talked about the 3 main ones, sine, cosine, and tangent. And that's because I don't want to weigh you down with 12 different formulas. So what we're going to do instead is we're just going to take the equation I already gave you and use its reciprocal. So let's say, for example, you had a question that said something about cosecant of u minus v. Well, we know cosecant is the reciprocal of sine, and that works for any angle. So cosecant of u minus v would be 1 over sine of u minus v. And then you can just use the formula that we just learned. Sine u cosine v minus cosine u sine v. Now it's very important that you guys know you're taking the reciprocal of the entire formula. It has to be 1 over the entire formula. You can't take the reciprocal of each trig function separately. That would not get you the right formula. Let's take a look at one more quick example, cotangent. So if I had cotangent of u plus v in one problem, I'd say, okay, well, that's the reciprocal of tangent. So that would be 1 over tangent of u plus v. And the only difference is the formula for tangent of u plus v is already a fraction. So I'm not really going to do 1 over. I'm just going to take it and flip it. And this is what it would look like. For tangent of u plus v, you have this on top and this on bottom. I just flip those, and I have a formula for cotangent of u plus v. So we have a total of 6 formulas, 2 for sine, 2 for cosine, 2 for tangent. Those come in pairs, and they have a lot of similarities, a lot of patterns, makes them easy to remember. If you need a formula for the reciprocal, just use the reciprocal of one of those 6 formulas. So let's go ahead and do an example together. We're going to go back to what we have been working on most recently, and that's solving equations. So we're going to solve for x, and I said on the interval 0 to 2 pi. So remember, that tells you 2 things. It tells you, number 1, we're answering in radians, and number 2, you don't have to worry about the repeats. Don't worry about plus 2k pi on this. Just give me the unit circle answers and stuff. Now what I notice in this question is I'm going to end up using 2 formulas because I have sine of x plus pi over 4, that's a sum. And I also have sine of x minus pi over 4, that's a difference. So we're going to end up using both formulas. Let's do them one at a time. Let's start with this. Let's make this our u plus v. So the formula for sine of u plus v is sine u cosine v plus cosine u sine v. And if I apply x for u and pi over 4 for v, I get sine x cosine pi over 4 plus cosine x sine pi over 4. Okay, now I need to do that again because over here I have sine of u minus v. So let's say I'm going to use the formula for sine of u minus v. That's sine u cosine v minus cosine u sine v. I'm writing kind of small because I have to squish a whole bunch in there. But I'm going to do the same thing. I'm going to put in x for u, pi over 4 for v, and what I'll have is sine x cosine pi over 4 minus cosine x sine pi over 4. And then the last thing to do is remember this was an equation, so I still have this equals -1 on the end. And now what I've done is I've done exactly what the formulas are meant to do. I took the sum and the difference and I broke it apart. So I have only x's or pi over 4s for my angle. Now the next step is to clean everything up. It looks like a mess, but this one actually cleans up really nicely because right here, if you look at your second and fourth terms, those are the exact same terms with opposite signs. One's positive and one's negative. That means they just cancel each other out. Now the other 2 terms that are left over are the exact same thing. It's sine x cosine pi over 4. And if you add 2 of them, you just get 2 sine x cosine pi over 4 equals -1. Now what we have right here, we've simplified a lot, we've cleaned it up. We have a very important concept here. The difference between our 2 trig functions. Sine x, because it has an x in it, is a variable. We're going to leave that for now. That's what we're solving for. Now cosine of pi over 4 is not a variable. That's an actual math question. We can evaluate that on the unit circle. So let's do that. We have 2 sine x. Now, from the unit circle, cosine of pi over 4 is radical 2 over 2. And then we'll leave the -1 for now. So what we've done is we've gotten our big messy equation all the way down to just one trig function, just sine x. And now it becomes a kind of day 1 solving equations question. We just need to solve for x. So what I would do is cancel these 2's. We're multiplying by 2 and we're dividing by 2. That cancels. So what we'll end up with is radical 2 sine x equals -1. We want to isolate that trig function, so I'm going to divide by radical 2. Cancel that out. we get sine x equals, now I'm going to take this negative 1 over radical 2, and I'm going to rationalize it and get negative radical 2 over 2. So I'm ready to answer the question. Now remember, on the directions I said we are answering on the interval from 0 to 2 pi, so I'm giving my answer in radians, and I'm doing unit circle only. So we're going to get two answers for this question. There are two places where sine is negative radical 2 over 2. They are both on the bottom of the unit circle. Remember, sine is a vertical component. If it's positive, it's up. Negative is down. So I'm going to get two places. That would be 5 pi over 4 and 7 pi over 4. And those two are my final answer.